Hi, I'm Matt Little. I'm the Director of Counselling and Education at EmpoweringAwareness.Asia, and I'm a proud sponsor of this podcast.
Hi, I'm Fazeel Gareeboo. I work at EA. I work on a small team. We do continuous integration. And what continuous integration is ideally you want your product to always be stable and or know when it's broken as soon as possible. And what continuous integration does is every time someone checks something in, whether it's code or art or some design file, we will build the game. So we will verify that the game still builds. And if it's broken, we send out messages to people who have recently checked in so they know they've broken something. And then we also automatically test the game by copying it to consoles or PCs, and we run some scripts that tests the main parts of the game. And again, we want to make sure that the game still runs and doesn't crash. If it crashes, then we send the crash information to, again, the people who checked in last so that they know they've done something wrong and hopefully they can fix it. But even if no one takes action, at least that information is available to the leadership of the game team. So they have the information to show that at this point in time, the game was working. At that point, it broke, and they know who changed the game between those 2 points. And they have the data to chase down the culprit, so to speak, and hopefully make sure that next time either they don't break it, or if they do break it, when they get the message, they actually fix the game instead of ignoring the message. I think it's a really important part of at least game making, but I think software development in general, particularly if it's a fast moving development where you have a lot of people making a lot of changes all the time, because what tends to happen is when someone checks something in and they've actually broken the product, but they don't realize they've broken the product because they're only testing one part of the product, or they're testing their code and they're not including other code that has been checked in the meantime. What happens is that it can take a long time between that defect being introduced in the game and someone coming to them and saying, hey, you've broken the game. This is your check-in. This is how you broke the game. Please fix it. And anyone who's done software development will know that the longer it takes to find or report a bug between the bug being introduced and the bug being reported, the more expensive it is to fix. The worst case, of course, is you introduce a bug, it crashes the product in some circumstance, nobody notices, the product gets released, the customers report it. So then not only do you have to fix it, you have to re-release. So it costs a large amount of money at that point when the product has been released. So the speed at which a defect is detected and reported and ideally fixed is really critical, and it plays a really outsized effect on the cost of developing software.
So what are the challenges that you face usually?
We have a lot of challenges. So I think, as I mentioned, first is that maybe people are not paying attention to their email, or the messages that we're sending them telling them that, hey, the game doesn't compile anymore and you checked in something between those 2 times, so please take a look and see what you might have done to break the game. So that's our first challenge. Now there are some solutions to that challenge, but it's difficult to implement, maybe for cultural reasons. So one example of a way to fix this problem is to provide the automated tests that we run to the developers. And so, of course, we expect someone who has changed something in the game to recompile the game after they've checked something in. That's like a minimum test that you want. But if they've broken something in a part of the game that they don't normally test, they can run the automated scripts and verify it. It's an automated script, so that means they don't actually have to sit at their computer. They can just kick it off and get the results back. And so one of the things that you could implement as a team is to ask all of your software engineers to make sure that they're running the tests before they check something in, and have a dashboard that shows who has run the tests. And so next time when your mainline breaks, you can go and look who checked in the breaking code. And then you can also look at whether that person ran the tests or not. So, of course, if most likely they didn't run the tests before they checked it in. So then you can have a conversation with them and say, hey, why didn't you test it? I mean, we provided you automated testing, so it's easy for you to test. So why didn't you test it? And you have that conversation maybe 2 or 3 times, after which the manager has to get involved and it's a performance issue. But that's one of the ways where you can, in a sense, prevent the defects from even getting into the code base by getting people to do better testing. But of course, a programmer's time is very valuable, so we don't want them to have to spend a lot of time testing. We want to provide them automated tools to do the testing. And an even better way is to, in effect, like submit their changes and have it tested in the background or in the cloud. And then they get a response back saying either it passed the tests and the changes have been submitted to mainline, or it failed the test and here are the failures. And of course, it hasn't been submitted to mainline, so you have to fix it. So that's one of the challenges. The second challenge is, of course, the bigger the software, the harder it is to do this. If you're thinking of a piece of software we don't talk about kilobytes anymore. We talk about megabytes as a minimum, right, for a piece of software. So if it's a megabyte versus a gigabyte, that's a big difference. If it's 100 gigabytes of software and it's just one lump, then you can imagine how it's going to take a long time to compile.
Okay.
It's going to take a long time to copy that, let's say 100 gigabyte software to a console, run the tests. So it plays against our desire to test it as quickly as possible and to provide the results back as quickly as possible. And of course, there are solutions to this. One of the solutions would be to modularize the software so that we are only, in a sense, testing the components, the bits that have changed. And so that might reduce the amount of data that we have to deal with when compiling. That might reduce the amount of data that's involved in copying. So let's imagine the software is made up of a bunch of DLLs. Then you're only copying the DLL that's changed as opposed to the whole package. And so that's one of the solutions. It's not an easy solution if it's a large piece of software and if it's kind of old, if it's more than 5 or 10 years, you get into the problem of if it ain't broken, don't fix it. And the software is so old that people are very afraid of changing anything because there is the risk of breaking things, and so it takes a long time. So I would say those are probably the main challenges that we have when doing this type of thing. I mean, ideally, we would like, I think we want to it's better if we automate the whole thing. And I think some companies do that. So what would happen is that you have a main line, you have automated compilation and automated testing on the main line on a continuous basis. And then if they find a defect in the main line, they will automatically revert the change lists. So that is a way of kind of protecting the main line. But sometimes it's not feasible in some circumstances. You have to involve the individuals. So that's where we're at right now.
Okay. So if there is enhancements and if there are additional features or functionalities added to the application, so how it will be done?
So it depends how big the changes are. If the changes are small, then typically the developer will, if it's a bug, for example, the developer will get the bug description and the details for reproducing the bug. They will make sure that they can reproduce the bug, and then they will work on debugging the issue, finding the fix, and once they've found the fix, they will test the fix for fixing the bug specifically, and then they test the fix to make sure that it hasn't broken any major other parts of the product. And once they've verified that, I think most companies these days have what they call a peer review system, so that they will submit the change for peer review. And then once it's passed the peer review, they can then submit the change. And then depending on what you have set up as continuous integration checks, either they submit it directly and then the system takes care of it, or they submit it to an intermediate step that checks it before it submits it. And now if you go to the other extreme, if it's a change that is very, very big, and it's going to span multiple releases of the product. Let's say it's going to take 3 years to implement, and you're doing a major release every year. Then that feature, at least in theory, you can't make it part of the mainline because you're going to have half done bits after a year. And so there are two strategies to do that. One is to have a kind of a feature branch, so that you branch the code off and then implement the feature in that branch. And then when you're ready after 3 years, then you can merge it into the main branch. The challenges with that is while you're developing it in the feature branch, the main branch is still changing. And so you have to decide how often are you going to sync to the main line and make sure that your code is the same as what's currently in mainline. Now, one strategy would be whenever we do a release, you do a sync. But that's going to cost you money because you're going to have to integrate, you're going to have to test, you're going to have to fix. Another alternative is to do the work in the main branch, but put the feature behind a feature flag, so that you leave the feature flag off until it's completely done. Then you can flip the feature flag, and then your users then have access to the feature. So it really depends on how big the work is, typically how long it's going to take versus how often you release. And so that's how you can manage that.
So how usually your developers work?
That's a good question. Obviously each developer is different. We are all different people. We all have different ways of doing things. But the main things are, first, I would say it doesn't apply to just our developers. Hopefully it applies to any developer. First step is make sure you know what you're supposed to do. So if you're fixing a bug, make sure you have access to the bug description from some piece of software, whether it's Jira or some other piece of software. So first you have a description of the problem that you're trying to fix, or a good description of the feature that you're trying to implement. Of course, these days, in terms of features, in terms of bugs, the main thing is how are you able to reproduce a bug, and do you agree that it's a bug? Because sometimes people call features bugs and vice versa. So that has to become clear before you do anything. And same for a feature. If you're developing a new feature, you have to understand really what is it that you are asked to implement. And I think as a developer, it's good that you not only try and understand in terms of programming wise what the work is, but I think it's also good to understand how it's going to affect the user. Why are we doing this for the user? Strictly speaking, in most companies, it's probably the role of a product manager to understand what the user wants, what the user needs, etc., etc. But I think it's useful for a developer to also really understand what the product is doing for the user, because the developer has a unique view into the product. They understand the code. Maybe there is a better way to do this, a cheaper way to do this, a faster way to do this, a better way to do this, that maybe the product manager isn't aware of because he or she doesn't have visibility of the actual code. So I think it's important for the developer to understand why are we doing this in terms of what's the benefit to the user. Of course, for a developer that's just starting, it may be hard to do. So it may take them a little while to understand the product. But for someone who is established, I would expect them to understand the product so that first of all, they understand why are we doing this? What's the benefit this is going to provide to the user and how it's going to make the product better. And then once they've satisfied themselves that, yes, this is a good thing, then they can go, okay, how do we actually implement this? Architecturally, code-wise, algorithm-wise, what's the best way of doing this? And then there's like user interface. So sometimes the user interface of the feature is already defined, so then they don't have to figure it out. But again, still, I don't know how many times as a developer, you take a requirement document or a requirement specification. You implement it exactly as it's specified. You give it to the user and they start playing with it and they go, no, that's not what I wanted. But that's not what they mean, because they said what they wanted and that's what you've delivered. What they mean is that's not what I need, because they realize when they start using it that something isn't quite right or something doesn't quite make sense. And when you're drawing the UI on a piece of paper, if you haven't done the proper usability studies, you sometimes miss those things. And maybe there are some things that you just can't cover with a pen and paper simulation. Things like how long does it take when you click on the button before something happens, or those types of things, like the dynamics that you can't cover with a pen and paper. Maybe they surface when they actually use it. And that's when you go, it's not quite what I need. Can you make those particular changes? So I think as a developer, we need to be open to the fact that we've implemented something, but I would say 80% of the chance it's likely to come back to us for some changes because they've realized that's not exactly what they want. Now, some developers get frustrated by this. They go, hey, I did exactly what you want. You're wasting my time. But not really, because when the person wrote the specs, they didn't know that that is what they wanted. They had to have this thing, play with it. Then they crystallize exactly what they actually want. And so it's not really wasting their time. And in any case, they're paying for your time anyway. So how can they be wasting their time? Maybe you could argue they're wasting their money, but even then, I mean, they're asking for it. So just do it. So, I mean, I would say, first of all, verify, understand what is it that you have to do, first of all. Then verify the value that it's going to provide to the customer. And then implement it, but be prepared for changes coming back that you have to tweak it. And I think that's really our job. Our job is to make sure that we provide the greatest value to the customer. And with things like Sprint and Agile, we understand the iterative nature of things where you do it a part, you show it to the customer, you get feedback, you improve it, and then you give it back. And it's not the feature of just software. It's a feature of almost everything that we do. You know, you do something, I don't know, you brush your teeth, you use a particular toothpaste and you go, oh, I don't like this toothpaste. Well, guess what? Next time you go to the shop, you buy a different toothpaste. You try that one. So it's that iterative nature of things is in all the things that we do. Hopefully, if you're paying attention and you want to always get better, you're thinking about things and then you're thinking about how you can improve it. And then if it makes sense, you change it and you improve it.
Great. And to summarize, what is your responsibility?
So my responsibility, well, the responsibility of the team is to help the game teams keep the game stable during development. So as the game is being worked on, we want the game to be always playable at any time. We don't want someone like an artist to try and make a change to the game. They get the latest version of the game and it crashes as soon as they try and run it. That's the opposite of what we want as a team. My particular role is to ensure that as a team, we're crystal clear as to what is our role. We do that. And when people ask us to do things that are not within our role, I need to say no and I need to explain why not. And then the other part is to make sure that all the team members are really happy and enjoy what they're doing. Because if you're not happy, you're not going to produce good. So this is back to this McCarthy thing where a great team, a product is a reflection of the team. So if you want a great product or service, okay, it's a service,
want a good team,
then you need a good team. And so my focus is to make sure that the team is great.
Wonderful. At last, as a problem solver, as a team leader, what is your observation about my work? You said last time, now you're seeing me doing more work.
Well, keep smiling and keep doing it.
So, have you seen any recent videos of mine? Like, what's your
I haven't.
observation?
No, honestly, I haven't. No, sorry.
Yeah. From last time when, when I took your interview, I have done, hundreds of interviews,
Okay.
of different company CEOs and, chief revenue officers and, people, people who are working on the business side of the technology, also people who are
Yeah.
architects, developers and
Yeah.
engineers, and also from
Yeah.
different parts of the world. So as an
Cool.
observer, as an experienced individual and professional,
Mm-hmm.
how these conversations, me talking with different country people who are different technologists who are working on business side of the technology, and also experts like you who
Mm-hmm.
knows how things are working and how you are able to solve the problems from, when which is unexpected, which happens something
Yeah.
which didn't happen before. So me talking and trying to know your experiences, how this is going to be helpful for me for my future and for my career.
I think first you have to at least decide where you want to go. Like choose what what do you want to do? Do you know what you want to do?
Yeah,
Do you know what you
I
want to
want to
become?
understand. Yeah. Yes,
What is
I
it?
want to understand it. Yeah, I want to work on the business side of the technology by understanding the development side of the technology first.
Yeah, okay.
And the
So,
leadership thing.
yeah, so I mean, I think if you want to do that, then you you always have to start somewhere, whether it's on the
Yeah.
technology side or on the business side. Uh, I think probably for you, probably start on the technology side. I think you are already on the software side. So however much you can spend on the software side, and then maybe pick a particular domain, because software is technology is vast. So pick a particular area. Now, of course, these days AI is the big thing. So maybe pick something in AI, um, but keep an eye on things. Maybe quantum computing is going to be the next big thing. So maybe keep an eye on that one as well, because usually it's easier to either get a job or make progress in fields that are expanding. And so keep an eye on those two areas. And then if you can get a software job in one of those two fields, and then have conversations with people on the business side, understand the business, maybe take some courses on the business side. A lot of people do what they call a master's in business administration. So something like that could help you. But even if you don't like take an actual course, read things about, business and talk to people about business. And, you have a lot of contacts now. So as you're thinking about things, once you've started working at a company, as you've started working and you started understanding what they're doing, and maybe there are some questions that you have, and you ask your business colleagues, maybe they don't know the answer, or maybe they tell you, no, it can't be done. But you have a bunch of people that you can go, hey, I'm working at this company. I have this idea. What do you think? How could this be done? So you have a lot of people that you can ask, that they can give you ideas if you can't figure it out for yourself. That would be one thing. And then, of course, ask for help, wherever you are. But the more specific the ask for help is, the better help you can get. However, sometimes people will say, hey, I don't know what to ask for help about. Can you help me? So that's like the most general one. But I think ask for help is the most powerful thing.
Definitely. Can I put this video on my YouTube channel with your permission?
Sure.
Also, can I put this audio and video clip on my podcast, website, internet, social media, everywhere with your
Yeah,
permission?
sure.
Yeah. Do you want to share your socials to my podcast listeners so that they can
Yes, you
follow
can.
and
I think you
learn
can. I
from
think you
you?
have my LinkedIn and, yeah.
Can you spell it?
I'll probably send it to you on WhatsApp. It's probably easier for me.
Yeah, yeah.
Is that okay?
Yeah, that is okay.
Yeah.
But the
Oh,
podcast listeners who are listening this on the podcast who can't see this, can you
oh,
spell
okay,
it?
okay, 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 okay. Let me see if I can find my LinkedIn. That's a good point. 1 second. Okay, my LinkedIn is the usual LinkedIn URL, which is www.linkedin.com, and then it's /in and then /F Gareeboo. I think that's it. Hold on, let me double check. Nope, that's not it. Hold on 1 second.
You can say your name. They can search and
Yeah,
type and find it.
yeah. My name is Fazeel Gareeboo, Fazeel EEL. Last name is Gareeboo, Gareeboo.
And your designation?
Development director.
So
Actually,
with this,
software
they can find
development.
it. So with this, they can able to see it and follow you and can learn from you.
Yeah, okay.
Thank you again, Fazil, for your valuable time and sharing
Yeah,
some of your experiences and answering to some of my questions.
sure. You're welcome.
Thank you, sir. Take care.
All right. Yep. Thanks. Bye.